Okay, EET 260 microcomputer applications people. We have I just doing this quick review thing here of a topic I think you know a lot about already. Just want to make sure, and so I thought we'd talk about electromechanical relays and solenoids, because we had talked about motors and positional servers and servo motors and DC motors and all that sort of thing, and we may talk about those some more. Electromechanical relays, I think everybody's familiar with the idea of taking a piece of soft iron and wrapping a wire around it. We put a current through that wire, it becomes magnetic. And up here we got a piece of soft iron that, nothing loves magnets more than soft iron. So we got a little spring here. So when we put the current through this solenoidally wired coil, it pulls this thing down, and when we release the current, the spring pulls it back up. So the idea of a relay, and I happen to have a relay right here, and I'm using a, if you can see it over there, I've got a gel cell right there that I'm using for a power supply, because this is a 12-volt relay, and I might be able to get it to fire with like 9 volts or something, but this is more of an industrial relay. Okay, so this thing right here is a relay, and you can see it's got a coil of wire wound around what looks like some metal, and we'll see what happens here. I'm going to take I've got the let's see, can you see it there? I've got the coil hooked up. The red and green wires are the coil. And let's see if we can avoid shorting out anything on the desk here and blowing up anything, even though it's much more entertaining to do so. So here's the coil, and when I actuate this thing, you can see, and I wonder if I can even get this up here and do sort of a close-up. I'm going to try to, or better yet, I'll bring this guy down. And let's see if we can get him focused. See if he'll focus at this distance. There we go. And when I operate this thing, you can see that down in here, the coil attracts the metal when we put in the thing. And it's on sort of a hinge rocker pivot point, and you can just make out, you can just make out that there are open contacts. Oop, my bad. Open contacts right there, and there are closed contacts right there. So when I when I operate this thing, I close these normally open contacts, and I open the normally closed contacts over there. Not easy to see, is it? See if I can, maybe I can get a little more light into this thing somehow. No, I'm right in my own shadow. Well, we buggered that up pretty well. Let's see if we turn it over this way and shine the light in from the other side. It might work a little better. There we go. Right. So now you can see again down here the magnetic pull-in. You'll hear people say, "Well, that the relay picked," meaning the relay operated, right? But just so you know the buzzword. Oh yeah, it picks the relay. So that picked. And you can see that this contact right there is normally closed. You can see that nice metal probably vanadium and palladium and every other adium in there, making a nice contact. And so this leaf of copper right along here and the moving leaf of copper right along the middle, they're normally closed, but when I operate it, they actually open up. It's hard to see it, but there's now a gap there, and the middle leaf of copper and the outer leaf of copper are now closed in their contact. So as I'm sure you've probably seen in previous classes, and I'll readjust this so we can see this, try to get the Cyclops out of the way. Okay. So as you can see here, when the relay operates, there's a set of contacts that are normally open. You'll see it abbreviated NO. I'm sure you guys have lots more terminology about it in your automation and control kind of stuff. But often this is pretty old kind of schematic symbol, but I like it because it's so almost pictorial. This guy comes down and closes, and these contacts make, and that's called an A form. In a B form, these are the normally closed or NC contacts, and this guy's here until the relay operates or picks, and this moves away and breaks that contact. And the C form is kind of the combination of the two, where you have a common wiper here that is normally closed to this top contact and normally open to this bottom contact, and when the relay picks, it comes down and closes. And that's what you could see with this relay. It's actually got two C forms. There's one, you're seeing it from the top of it, and there's the other, and they both operate when I put the fire to the wire here. So there's two different C forms operating there, and with two different C forms, as you've seen with an H bridge that we talked about for motor control, you can do things like you can reverse polarity, and you can there's all sorts of things you can do, and with a combination of these motors, you can build your classic stop-start circuit where you push a button and the relay closes and holds that button closed for you. So you just momentarily hit a button, the relay closes and holds it, and then you have another button that's normally closed somewhere, and you push that to stop the circuit because you break the latched current to the to the relay coil. I won't review all those circuits for you. I think you know those circuits. But these are relays. They come in all sorts of shapes and sizes. I think I have a couple more here. You've seen them. Here's this one's actually operated, if you can read that. It's operated by a 120 volt AC coil, and I think you guys have seen. You can see the size of the magnet inside of that thing. And it has, just like this other guy, two C frames. You can see them there, and you can see. I think you can see the normally open and normally closed contacts in this arrangement, or no, yeah. I think this one. I'm looking at the contacts. Yeah, I think it's this is a full C form on this side. This is a full C form over here. So that's a relay. I think you guys have seen really big relays that some people call contactors for operating things like 440 volt three-phase induction motor, that sort of thing. Here's another similar stand-up coil to what you saw. Stand-up relay. I mean, it's got the coil here, and you can see it's got C frame. I think you can see now it has C frames. It has two of them, and 6 contacts for the 2 C frames. You need 3 contacts each, and then 2 for the coil. And this one will, I think you can see this one operate as well. Maybe not. Oh, sorry. Yeah, it's got a little better travel than the other one. It's just hard to get light through these things. I probably should have a light underneath or something. But there it is, and you can see it moving the contacts. And that's, you know, that's a relay. Depending on what you're working on, you may use these kind of industrial relays, or you might see something like this. Some people would call a reed relay. This relay only has 4 wires on it. 2 are the coil, and the coil is wrapped around contacts in what they call a reed type arrangement. And it uses this. You can get these with all sorts of contact forms, but this one is just, I think, a normally open that closes when operated. And it's probably a 5 volt. Here's one. You know, this one happens to be shaped like a tube, and you can see 4 contacts on it. Same idea. These are just things I've saved out of boards. Here's one you can. I don't think you can see it too well, but you can actually make out the start of the winding. But again, 4 contacts, 3 on this side, 1 on this side. That's a reed relay, but you can find reed relays that certainly have more than 4 contacts. Here, I believe, here's one. This is in a dual inline package. You're probably going to see this in surface mount nowadays, and maybe even smaller. Magnacraft is famous for making these kind of reed relays, but there's, you know, probably a couple coil contacts. This might even have 2 C frames in it, I don't know. So just kind of mentioning that just for general education purposes. And the other thing I mentioned is there are mechanically latching relays in addition to regular relays. These are relays that you operate them. The coil operates with polarity, so you apply current momentarily and it latches in one position, and then you apply the current in a reverse polarity, and that will unlatch the relay, and it'll toggle the other way. So the relay actually has kind of a bistable state associated with it. All right, we'll get done messing with that. And I wanted to mention solenoids. And solenoids, sorry, what a pain this thing is, the light. So solenoids, okay, definitely worst instructor of the year. I'm going to take that up. Maybe it actually works better when I block some of the light. So here's the deal. We have, this time we have a bobbin, and we wrap the wire on the bobbin. Okay. And so the wire is wrapped around this bobbin, and this one has a square hole. We could just as well have a round hole. And we've got our soft iron bar. And as you might guess, when you energize the solenoid, it pulls the iron bar in here, and that can be connected to rods and levers and do all sorts of things. It can it can be part of a relay and operate a contactor or something, maybe even a real high voltage contactor in a power switching yard for the power company. Or it could also be, it could also rotate in the starter motor and bend it so that your starter motor drives the flywheel of your engine and starts your car. That's a solenoid. All sorts of actuators can be based on a solenoid. And I have here just an amazingly powerful solenoid. I'm joking, of course. Now you can see this thing. It's wrapped on a bobbin. It's plastic, and there's you see this black metal thing, gray metal thing in there, and that's attached to this plastic plunger. And the plunger has a very soft spring on it. And so if I take and I hook this thing up to 5 volts, it pulls the plunger in. When I release it, the spring pulls the plunger back out. So there's a solenoid, and that could operate a switch. If it were a bigger solenoid, it could operate some valve. And in fact, this, I think, I got this stuff off of eBay. It's nothing fantastic. I'm such a cheapo, but I think things like this are used to operate some valve in like an aquarium or something, something really small. It's just, with a transistor coming off your microcontroller, you can easily operate this thing. Oh, I lost my ground connection. Perfect. So, and there's the, see if I can rest this thing in here. So there it is there, and try to get my fingers out of the way. And there you can see it operate. Maybe this one I don't think is powerful enough to operate a switch on a model railroading type setup, but they certainly have those. And so you can send a command to a track switch and send the 505 into the freight yard and for unloading or whatever it is you're going to do. So anyway, relays and solenoids, all that just to say those two things and mention them in review. All right, more videos coming up, and we'll talk soon. Take it easy. Bye.